Okay, guys, I'm glad you came back for more from the stoichiometry unit. Today we are going to discuss 12.2, and I'm going to warn you right now, this is the part of the unit where students have more problem. So you need to pay very, very close attention. I need for you, like I always say, do not just sit back and listen to me. I need for you to go right now. Pause the video. Go get some paper, something to write with, a working calculator, and a periodic table. It doesn't matter how much you sit down and listen to me. If you don't really take part, you don't practice what I'm doing, you don't enter those numbers on the calculator, it's not going to help you much. Okay, so be active listeners. I need for you to solve those problems with me. Pause the video to solve it even before you see the answer. Alright, so good to have you back. The objective for today, we will construct mole ratios from balanced chemical equations and apply these ratios to in mole-to-mole stoichiometry calculations. Here's the second part. Calculate stoichiometric quantities from balanced chemical equations using units of moles, mass, representative particles, and volume of gases at STP. I am going to give you some generic solving method for all types of problems you will have in this unit. Okay, instead of using specific numbers, I'm just going to use some variables, set up the different types of problems you will be solving. So let's just say they give you moles X. Okay, this is your given, moles X, and they ask you to solve for moles Y. Okay, doesn't matter what element they give you the moles of element and ask you to find the moles of another substance. Okay, this is what you always do. Always start with your given, which is X moles. This is what they gave you, abbreviation moles. Always use your conversion factor. We did that last lesson. You always put the moles of the given down here. This is moles X. Okay, and then you always put the mole they ask you for on top here. What do you put in front of those moles? In front of those moles, you always use the coefficient from the balance equation. Okay, that means you always start with a balance equation. Whenever it is a mole-to-mole stoichiometric problems, you always use the coefficient of those substances from a balanced chemical equation. That's what we call mole-to-mole. Now, I wish I could just stay on this page, but I cannot. How about if they give you moles X? They ask you for grams. That same substance, X. They give you moles X, they ask you for grams of that same substance. This is what you do. You start always with the moles of your given. This is X moles. Okay, always use conversion factor. You put the number, the moles they gave you down here. This is moles X. And then you put the grams. The unit for mass is grams of that same substance X. Because this is a moles to grams always put a 1 in front of that moles. In front of the grams, always put the molar mass from the periodic table. It is a moles to mass. You always use the 1 mole and molar mass of that substance from the periodic table. So this stoichiometric problem is moles to mass, but the same substance, the same one. Let's move on. Cannot stay here. How about if they give you moles of substance X, but they ask you for mass of another substance? They give you moles of one thing, they ask you for the mass of something else. This is what you do. You start with the moles of the given. This is my X moles. That's what they gave me. I have no choice to start with the given. Like always, I put my conversion factor. Here is where students get in trouble. This is my given. I write down moles of my X. I cannot go to grams of the other substance. I have no way to know if I have mole X, this is the grams of something else. I cannot do that. The only thing I need to do, I need to find moles of that other substance. Okay, so this is my moles of my given. This is the moles of what they ask me for. Because it is a moles to moles, I use coefficient from the balance equation. Okay, coefficient. But I'm not done. They did not ask me for the moles of substance Y. They asked me for grams of substance Y. I need another conversion. I put the moles of Y that I have up here, down here, so I can cancel it out. And then here I can do grams of substance Y, since I have the moles of substance Y. Because it is a moles to mass, I put a 1 in front of the moles, and here I put the molar mass of substance Y. So it is a 2 steps problem. 2 steps. I cannot go from moles X to grams Y unless I find the moles of Y. So mole is always a bridge to go from one substance to another. 2 steps problem. Here's another one. They give me grams X, but they ask me for moles. This is not bad. It's reverse of what we already said. Let me go a little bit faster here. This is grams. Okay, this is X. Okay, use conversion factor. I put my grams here because that's what I want to cancel out, and then I put the moles here. Okay, because it is moles, grams, I put a 1 here, and I put the molar mass here. Not bad. Okay, so this is a mass, 2 moles, but of the same substance. 1 step. How about if they give me the mass of X, but they ask me for moles of Y? Okay, always start with the grams of X. Conversion factor. I have to put grams here so I can cancel, and I have to put moles, but I cannot put moles Y. Okay, because I don't know the relationship between grams X and moles something else. So I have to convert it to moles X first. Okay, because this is a moles grams, I put 1 here, and I put the molar mass here. Whenever I have grams, I use the molar mass. Whenever I have a conversion factor that has 2 different units, I put a 1 in front of that mole. But I'm not done because they did not ask me for moles of X. They asked me for moles of Y. I need another conversion factor. I write down moles of X here, and then I will write the moles of Y. Now I can go from one substance to another. And then whenever I have moles to moles, I use coefficient from the balance equation. Okay, and then the last type, the last one, They give me mass of X. They ask me for mass of Y. Mass of X. They ask me for mass of Y. Okay, I have to start with my given. Let me start with grams X. And then I use conversion factor. I have to put grams X here. And then I cannot go to grams of Y. I don't know the relationship. I have to find the moles. Cannot do anything without the moles. But moles of Y, moles of X. This is moles, grams, 2 different units. I put a 1 in front of moles. Because this is a grams, I use molar mass. Molar mass. Grams X, gram X cancel out. Now I have mole X. I use another conversion factor. I put moles X here. But I still cannot go to grams Y. Don't know the relationship. So I need mole Y. That's the only way I can switch from one substance to another. So because it is a moles to moles, I use coefficient from the balance equation. I'm still not done. Because I cross out moles X, cross out moles X. Now I have moles Y. It's not what they asked me for. I need another conversion factor. I write down moles Y here. And then because I have moles Y, I can go to grams Y. Because it is a moles, grams, I put a 1 here and I use the molar mass of Y. I cancel out moles Y. I will end up with mass Y. Okay? Now, why don't we do some practice? We have our calculators. We have periodic table. Let's see what we can do. Okay, how many moles? Okay, let's underline. They ask me for moles. Moles of what? Moles of ammonia. Question mark. Are produced when 0.60 moles of nitrogen. Okay, my given is moles nitrogen react with hydrogen. There's nothing I can do unless I write a balanced chemical equation. I will not see the relationship unless I write the balanced equation. So what are they talking about? They say how many moles of ammonia are produced. Ammonia is produced. So I put produce. This is ammonia. Okay, I need for you to really know the formula for ammonia. Because the word has nothing to do with the formula. You need to know it. Now they tell me when nitrogen, because nitrogen is diatomic, I write N2. And react with hydrogen, hydrogen is diatomic, I write H2. And I have to make sure now it is balanced. So I have 2 nitrogen on the reactant side, I put a 2 here. And then I have 6 hydrogen, I put a 3 here. Like we said in the part 1, this is what we call the Haber process. This is to make ammonia. So let me start with my given. My given is 0.60 moles. Students who just write down moles without the actual substance, they will get in big trouble. You have to write a substance. They tell me nitrogen. I use my conversion factor lines always. I put the given down here, moles nitrogen, and I write what they ask me for. They ask me for moles ammonia, NH3. This is not bad. So I check the coefficient for my balanced chemical equation. The coefficient for nitrogen is 1. The coefficient for ammonia is 2. That's what I use because it is a moles to moles. And the answer is 1.20. They gave me 2 significant figures, so it is 1.2. And you have to write a unit. Moles is not enough. I have to write moles ammonia. So this is my answer. Let's move on. Calculate the number of grams. They asked me for grams. Underline grams of what ammonia? Question mark. Produced by the reaction of. Wow. They give me grams. Grams of what? Of hydrogen. This is my given. With an excess nitrogen. and they were nice enough to give me a balanced chemical equation. So let's go. Calculator, periodic table. Let's see what we can do. Given 5.40 of what? Grams of what? H2. Conversion factor. I have to put my given, the unit of the given right here. Grams of hydrogen. I cannot put grams of ammonia up there. I have to find the moles of the given, always. I need moles of my given, which is H2. It is moles grams. I put a 1 here, and the grams is that 2.02 for H2. Is that right? All right. So let me start crossing things out to see where I am. This is gram hydrogen. This is grams hydrogen. I have moles hydrogen, but they ask me for grams of ammonia. I still cannot go to grams ammonia. I need another conversion factor that will go from moles of hydrogen to moles of what they ask me for. Cannot go to grams. This is my NH3. Because it is a moles to moles, I will use the coefficient from the balance equation. The coefficient for ammonia is 2. The coefficient for hydrogen is 3. Okay, let's see if I set up it right. Let's see if I can cancel. This is moles hydrogen. This is moles hydrogen. So now I have moles ammonia. I can go to grams ammonia. Let's see if I have space here. So I write down moles ammonia down here, NH3, and I write now I can go to grams ammonia. Because it is a grams moles, I put a 1 in front of the moles, and I need the molar mass of ammonia, which should be 17. Okay, 17 point something. 17.03. No one say anything, that means I'm right. Okay, so I cross out moles ammonia, cross out moles ammonia down here. All I have to do, I get my calculator right now. I do 540 times everything that is beside it. Time 1, which is 5.40, time 2, give me 10.80, and then times 17.03, and the answer is 30, right? 0.4. And they gave me 3 significant figures. They gave me 3, and then I have 3, but I do not leave a naked number. So this is grams. I am still not done of ammonia. Let's see if we can solve 2 more problems and we will stop. Let's do 2. Let's go together. Now, how many molecules? Molecules of what? Oxygen are produced when 29 grams. Wow. Of water. Okay, question mark here. Is decomposed by electrolysis according to this balance equation. Electrolysis, you use electricity to decompose water into hydrogen gas and oxygen gas. Let's go. So I have no choice to start with my given, which is 29.2 grams H2O. Don't just put grams. They ask me for molecules. There's nothing I can do without moles. If you don't know what to do in any problem in this unit, go for moles. Okay? Cannot do anything without moles. I cannot go from grams to molecules. Cannot. So I have to go to moles. This is grams water and moles water. This is moles grams, so I put a 1 here, and the molar mass of water is 18.02. Okay, I cross out unit. This is grams water, grams water. They ask me for molecules water. Okay, another conversion factor. I want to cancel moles water and molecules. You can go anywhere with moles. Molecules. Don't abbreviate molecules as MOL. Okay, this is 1. This is moles. I put 1. Molecules is the Avogadro's number. 6.02 times 10 to the 23rd. Alright, so I cancel out moles water. I get my calculator. I have to be extremely careful now because I have scientific notation. So it is 29.2 times, put this in parentheses please, 6.02 times 10 to the 23rd. They are side by side, multiply, and then divide that by 18.02. And the answer is 9.69 times 10 to the 23rd molecules oxygen. Did we use oxygen? Okay, so this is grams water to moles water. We made a mistake, guys. We cannot go. This is not water. They did not ask me for molecules water. They asked me for molecules oxygen. So I need to do one more step. Sorry. Okay, I need to do one more step. I need to go from water to oxygen. I cannot go to molecule oxygen unless I have moles oxygen. So let's find moles oxygen. This is moles water. This is moles oxygen. Balance equation. This is 2 moles water. This is 1 mole oxygen. So I cancel out moles water. I have moles oxygen. Now I can go to molecules. This is moles oxygen, and this is molecules oxygen. I did it for water. It's not what they asked me for. That's why you should always go back and make sure you answer the question. This is 1 mole oxygen, and this is 6.02 times 10 to the 23rd molecules of oxygen. And the answer should be half of what we had before. It is what? Okay, 4.88 times 10 to the 23rd molecules oxygen. Why? That's why it is important that you underline, because I quickly went back and checked what did they ask me for. Did I answer the question? Let's see if I can do one more. If I have more than that, I won't do it. Oh, oh. Okay, I think I will have to stop here. Let me see exactly where we stop. And then in part 3, I will have to do a little bit of this before I start the actual lesson for 12.3. Thank you very much for your kind attention. Make sure, guys, you practice and practice by doing your homework. So I hope you have a wonderful day. Bye.